Welcome, everybody. My name is Ben Goldstein. I'm the managing editor of Aviation Week's Advanced Air Mobility Report, and I'm pleased to be joined here by a distinguished panel of guests to discuss the topic of drone integration, which is becoming increasingly important as we talk about commercial drone services at mass scale, as well as eVTOL air taxis, which will be sharing the same airspace in many cases, in which eventually may become autonomous or become remotely supervised. So I'd like to introduce my panelists. We have, to my right, we have Juan Carlos Campbell, Director of Research and Technology at Boeing, and hopefully, if I get your title wrong, you can correct me. We have Yvonne Winter, Founder and Chief Operating Officer of FlyNow, developer of a single-seat personal air mobility vehicle. We have, this is not Lucas, this is Rolf Stuber, the CEO of Smartflyer, which is developing a hybrid electric aircraft. And we have Lucas Marchesini, I hope I said that right, the CEO of Manta Aircraft. So, welcome to our guests. And I'd like to dive in now. To start off, I want to explore the subject of urban air mobility. So we have startups like Joby and Archer, which are talking about launching air taxi service with eVTOLs, including in the UAE, as early as next year. Initially with smaller numbers of aircraft, but eventually they plan to scale up to hundreds or even thousands of aircraft in any given large market. So at the same time, right, we see an explosion in commercial drone operations ranging from deliveries to medical transport or emergency search and rescue, among many other applications. So to my panelists, what are the largest challenges facing cities when it comes to incorporating these new types of urban air mobility aircraft at the same time as large numbers of drones? How do we accomplish both at the same time without jeopardizing safety? And how do these aircraft and drones ultimately coexist together in a way that doesn't lead to dangerous outcomes? So, Juan, if you'd like to take it, and then the rest of the panelists can chime in.
All right, so if no one starts, I will start. As you rightly pointed out, there are many different vehicles. First of all, it's the small drones, which are operated under UTM. Then you have these eVTOLs, like you mentioned, Archer and Joby and so forth, and as well, transport, aviation, etc. But there is a gap in between, which are the automated versions. When it comes to firefighting drones, when it comes to medicine delivery, heavy cargo lifts, and as well the personal air vehicles, which are automated. And the challenge that we do have is that all these kind of vehicles will be operated in a condensed air space. And if you imagine that you have thousands of these vehicles in the same airspace, then we need to, as you rightly pointed out, avoid collision. How do we do that? First of all, I think we need to bring everything under one roof, and this can be only air traffic control. Everything has to be controlled by the government so that we can have a safe system running. At the same time, of course, we do need ADS-B, we need sensors, and radar for collision avoidance in each vehicle. And then we have a whole system running that is driven by AI. Because currently, when you look at air traffic management, one air traffic controller can take care of approximately 25 airplanes. When you have thousands of vehicles, it's not feasible that a person takes care of. So we have to have a highly automated, safe, scalable system running that prevents the different vehicles to collide.
Yes, I Can you hear me? Yes. For us, the focus is fully autonomous eVTOLs. These will be flying above 2,000 feet. Okay. About 2,000 feet. So above the layer that you're talking about. Of course, we have the times when the things will be taking off and descending into vertiports, but we see that mostly governed by the flight rules that they are view of it.
Adibir? Well, I think I would like to add one aspect which is new in this panorama, because in the past in aviation we didn't see this. When we have all these vehicles flying and there is an emergency, so one of these vehicles has to divert, and it has to decide which is the trajectory it has to take. And it has to take a trajectory which avoids the others without disrupting the whole traffic, because we will have quite a high density of vehicle in the volume. Who is taking the responsibility of deciding which is the trajectory that the vehicle has to take? And here it drives to the other, let's say the bigger topic is, where is the intelligence of the system, these automated systems? Is it on board? Is it on ground? Is it shared? Because where there is the intelligence, there is the responsibility. And where there is the responsibility, there is the accountability in case something happens. And so I think it's one of the topics that we were discussing with the developer of these systems. How much intelligence to put on the ground and how much intelligence to put on the vehicle. Is the vehicle that has to decide where to go or not? Because today, if we think at the aviation today, it's a different story. No? Airplanes are very well separated. And the pilot can take some decisions, but mostly come from the controllers. So this is a question. I think it's open. Talking to a couple of companies which are developing new air traffic control systems, it's a question which is not answered today. And I think it has to come the answer from regulatory bodies, but also from the technology, what is affordable and what can be done. If you have a small drone, do we want the small drone to be able to decide what it has to do? And how will he communicate the others if he has a failure, what he has to do and what the others will do? So it's quite complex, I think. It's a very interesting topic. I haven't got an answer. I just wanted to pose the problem because I think it's one problem that we'll have to face.
Yeah, I think this is a very good point that you just addressed. And basically, it's very, very important that we have an air traffic management system, that we have a data processing system, a safe way between air traffic management and the vehicle. And then, as well as you said, autonomous. Is the vehicle deciding itself? And no air authority in the world currently wants an autonomous approach, because that is exactly what you pointed out, that the vehicle itself decides where to go and what to do. With an automatic approach, the vehicle flies in a predefined route from waypoint to waypoint. Exactly the flight plan that was filed through air traffic management to air traffic control. So what we could envision is that everyone, be it a piloted vehicle or be it an automatic flying vehicle, files a flight plan from air traffic management to air traffic control. The moment air traffic control approves the flight, the vehicle, when it comes to an automatic flying vehicle, is pre-programmed in the specific route. The moment it takes off, air traffic control takes over. And in this case, we make sure that only the government is in control of the airspace. And yes, in case of, a bird is coming, you need to hover, you need to have some kind of collision avoidance. And as well, in case of an emergency, you need to bring down the vehicle to the next alternate or bring it back to where you started from. And it's basically, you can imagine like tunnels in the road. And if each vehicle is supposed to stay in this specific tunnel, we have no issue. The moment that we set up different systems which are controlled by different bodies, we have a chaotic system. And when we go back in history, we had the same thing when cars were implemented. We had the horse carriages, we had the cars. There was a lot of chaos, a lot of accidents occurred. And then slowly the regulations were implemented. Now we have the chance to do it the right way from the beginning.
It's true. Air traffic management is one of the most important topics we have to solve in the future, because the airspace below 10,000 feet is uncontrolled airspace now. And if I speak to my country, Switzerland, or Europe in general, we have there not only the small drones, we have gliders, we have parachutes, we have everything, birds, and we have to manage not only the sea, we have to manage the avoidance. How do we avoid, or how do we separate the different traffic which is powered, and then traffic which is a glider or not powered? So this is really a big challenge, and I hope personally that we're not going to a controlled airspace only, that we keep the air on the lower sections below 10,000 feet, that we keep this air free for everybody. And this means we probably have to find technical solutions to see and avoid every kind of traffic.
Yeah, so the European solution for that is they are defining so-called U spaces, U- spaces, where there's different kind of vehicles and as well different applications are then operated in.
So when it comes to facilitating large-scale commercial drone services, the technology is largely already proven out, right? The problem is more from the regulatory angle as well as the public acceptance angle. There's a lot of skepticism in communities about having large numbers of drones flying around. Some people are concerned about data collection and privacy. For example, there are ethical questions that crop up. So, I'd like to hear from our panelists. What do you see as the pathway to enabling large-scale drone commercial services, both from a regulatory angle, but also from a community adoption angle, and how do we overcome some of the barriers that currently exist?
So, I think you made an interesting point that technology is maybe not so much the problem, or not the biggest problem. As other regulation, public acceptance. And I think in many of these areas, including what you just mentioned, the ability to put in place test and learn projects, validation projects, to work with authorities, to have public opinion, see how these things can work, is going to be a very important thing, especially as we move towards the fully autonomous solutions. So yeah, that's a big thing. Regarding privacy and data collection, and I think when you look at the eVTOLs, I'd say for the most part they're going to be either carrying passengers or cargo. And if you look at the vehicles that are doing that now, mostly helicopters, there doesn't seem to be much of a concern with them, because they're doing just that. They're carrying people and things around. So I think that the same can be, thought about the eVTOLs. But then, so that's the general idea. But then the other thing is, for eVTOLs to work in the airspace at scale, with a large number of them, one of the key tenets is that the system has to be able to know exactly what their location is at any given time. That being so, that makes for a very poor spying platform, let's say, So that in itself also should be something to be considered. And I mean, we could also look at the possibility of making sure we restrict certain payloads or equipage, and as with everything else, it's also about talking to the communities, talking to the public opinion, understanding what the concerns are, and trying to work together with those.
Yeah, completely agree. And we have to take this concern seriously. And when we show that these applications are very useful by first starting with medical applications, by rescue operations, and really useful operations, then people accept it more easily. Then we have to tackle the noise issues. This is very crucial as well. So our helicopter family has only 55 dBA in an altitude of 150 meters. This is more or less the sound level of a dishwasher. And if you imagine in an urban environment, you have in average 60 to 65 dB. The next thing is that we should not exclude people. And when we make it only a luxury experience for a few, it's hard for the other people to accept that. But if you come up with a device that is available and affordable for the broad public, then the acceptance is more likely to be there.
I think that's not a unique global problem. The acceptance in society depends which society we are talking about. I mean, for example, Sao Paulo, where hundreds of helicopters already fly since decades, that's no problem for them to accept as well eVTOLs. But in other countries, when I again speak of Switzerland, then I think in Switzerland it's really hard to establish a new way of transportation, especially when it's in the air, because we have limited space on the land. We probably could not build new vertiports. We have to use existing infrastructure, aviation infrastructure. This could be small airfields, airports, and heliports. But new equipment, new infrastructure will have really a hard way to establish. It's almost a mission impossible.
Well, I think infrastructure is a key point here. Not for the small drones, perhaps, but the bigger ones, yes. How to have them fly in densely populated areas. And so infrastructure and acceptance, as Yvonne was saying, you should show the benefits of these drones for everybody. Usually people are afraid of airplanes, and that's a fact. Majority of people are afraid of airplanes. So why should they have something flying on top of their heads if nothing comes in return to them? So this is a topic, and I think it's a lot about communication. I think all this communication and these events are very positive also for transmitting this concept. But I agree about the infrastructure. I couldn't agree more. I see it a very hard task to build infrastructure for eVTOLs in highly populated areas. Plus all the troubles that there are. They have to fly between buildings with turbulence. There is electromagnetic interference. There are what happens if even a controlled emergency landing has to be done in highly populated areas. These are all aspects that we have to answer before thinking about having the eVTOLs flying in the highly populated areas.
Excited to see the EHang was here, and EHang brought with them some examples of their EH-216, which is the world's first type-certified autonomous passenger-carrying aircraft. Of course, that aircraft is already operating in China, doing these sorts of aerial tourism and sightseeing missions, which is really exciting. But how far away is it that we could see something like that, in the West? For example, we have Boeing, who through their Wisk subsidiary is also pursuing an autonomous eVTOL. So, but what is the realistic timeline that we could be talking about actually putting a person onto a drone or an unmanned eVTOL and flying them around on commercial services? And what are the main major barriers you see in the United States as well as Europe to get to that point?
Yeah, so you're right. For us, through WISC, it's around the corner. It's the end of the century, of the decade. I'm sorry, and it's an ambitious task, but we're working hard to achieve it. Working with the FAA on certification of both the vehicle and the operating environment. Challenges. Well, I think we've discussed some of them. Again, I think it's crucial to work together. I mean, this has to be adopted globally, and this won't work if it's not deployed at scale. So one of the things is to have us standards, global standards, global regulations. That's one thing. Then, as I mentioned earlier, I think it's very important to have these test and learn initiatives that we can work with industry, with regulators, to show public opinion that these things do work. I'd say those are the key.
Thank you so much. I think this is a very crucial question. Of course, China is pushing a lot to push the barriers and to get going. I doubt that the Chinese model is expanded over the world. So it will be either FAA or EASA. FAA follows a bit more liberal progress, and EASA is on a good path. The question is, are they fast enough? And I mean, it's never ever vehicle was certified under the SC VTOL. And this is a major issue. And for the air authorities, it's quite hard because they never did the certification of these kind of vehicles. They never set up a system for the operation, so that they have to make sure that everything is proceeded in a safe manner, but at the same time, they have no role model to do. We are in a very good position at FlyNow Aviation, as we are per definition not a drone, as we have only 2 rotor blades, so we can rely on CSVLR and CS27 for very light rotorcraft and helicopter, and therefore we have a predefined certification route. We have the first certification milestone in specific category, and now step by step increase it. Start with cargo operations first, do 2 years cargo operations only, and then step into transporting people over populated areas in the certified category.
When we can see the first eVTOLs, it's really depending on the authority. It's depending on what kind of demands you require. For example, the Chinese authority already gave the approval. Next will probably be the FAA, and then we'll see hopefully EASA as well. But I think that's really a question of the authority, how long they need to get this type certificates.
I mean, there could be as well a Middle East approach based on European regulation standards. Just as a question.
Well, I think it's interesting also to notice which is the role of countries like China or UAE in this approach, because they see that EASA and FAA are quite slow on this. So they are pushing. China has taken a step forward. I think obviously it's something that is not exportable, I agree, but it's already stimulating, let's say like this, and giving a sign to FAA and the EASA and the other authorities that if they don't move, they are not the only ones regulating the whole area. And the UAE, we know that last year they have defined the certification framework for the helipad, or basically the landing pads for the eVTOLs before EASA and FAA. So it means that countries who want and who are willing to push forward this market or this segment will not wait for us. I mean, us as European and Americans, okay, to define the rules as it was before. So we have to hurry up. How? I don't know.
Or join forces.
Exactly.
So we have a few minutes left, but I'd like to close out by circling back to a topic we discussed at the outset, which is UATM or urban air traffic management. And these are solutions that are considered to be key to enabling high-volume drone and eVTOL operations. So to our panelists, and anyone could take this question, what do you see as the key characteristics, ideally, of a UATM system? Who should develop this system and oversee it? And how would a UATM solution differ from the existing air traffic management solutions that we have today?
Thank you for this question, because I think this is really, really on the spot. And I would really hope that we as an industry join forces together. We are now on a step to implement a new means of transport with all the hurdles that we do have. It's the low altitude economy. It's not only a new means of transport or a vehicle itself, it's an entire new industry, entire new economy. And we can only do that together. And there are so many hurdles and so many issues and security concerns. And you pointed it out very well, Lucas. And if we all come together and if we have partners for security, for cybersecurity, for air traffic management, for all the rerouting and the routing, and for a digital twin in order to be able to plan these flights, and have partners for the vertiport, as you mentioned, and infrastructure, very important. So not only the vertiports, but as well the digital infrastructure that is required, not only the vesicles, and then all the interfaces between air traffic management, air traffic control, and so forth. So there are so many issues, and no company can tackle all these issues alone, and no government entity can do that alone. So all the necessary stakeholders need to come on board and need to come on the table and define a safe way which is highly scalable, which is highly automated, which applies AI, which have the highest safety standards, and more or less defines an ubiquity so that can implement all kinds of different vehicles, because only then we really solve the issues that we have. And for this, to have my last word, we founded Sky Alliance for Automated Air Mobility, which is an international association where we have different companies participating from the air traffic management, infrastructure, vertiport, insurance, and all of that, so that we can really deliver a turnkey solution. And what we are now discussing with different government bodies is to set up a sandbox where they have their regulatory framework. We integrate not only our e-copter, but different other vehicles, and as well all these companies, and to try it out, to really have some pilot projects and see how this is feasible or how we need to adjust, so that we have a hard and software in the loop, jointly develop it, and then have a regulation and a setup that meets all the requirements for this new low-altitude economy.
Great. Well, I'd love to keep this conversation going. Unfortunately, we are out of time. But please, everyone, a round of applause for our speakers. They were great.